is still just, a tiny solar system.
Electrons like little planets.
Exactly. Well, get ready to update that picture. The modern view is way more dynamic, it's probabilistic, and honestly, a lot weirder and more fascinating.
It really is. Less like neat orbits and more like something else entirely.
Yeah, we'll get there. So our mission for this deep dive is to really unpack three core ideas. They're all connected.
Right.
It's the electron cloud, atomic shells, and the atom's own electromagnetic field. These concepts show how atoms actually work at the quantum level.
And the goal isn't just to list them, right? It's to show how they're like different views of the same thing.
Exactly. How the cloud's structure, which is governed by these energy rules, the shells, creates the atom's external presence.
The electromagnetic field, yeah. And that field dictates everything, how it bonds, whether it's magnetic, all of it.
Right. And why should you care? Well, because understanding this stuff is just fundamental. It's the bedrock for chemistry, physics.
Pretty much how the world works at the smallest scales. It's the invisible architecture.
Couldn't have said it better. So, okay. Concept one, the electron cloud. This is the quantum picture, isn't it? Not electrons fixed in place.
Precisely. Forget the dots on lines. The electron cloud is a region of probability.
Probability.
Yeah, around the nucleus. It tells you where you're likely to find an electron.
Okay, and that links back to things like the Heisenberg Uncertainty Principle.
That's a big part of it. You can't know an electron's exact position and its momentum at the same time.
So you talk about likelihood instead. Probability.
Exactly. We can't track its path. So the cloud is like a map of where the electron could be. And it has different densities.
Denser means more likely to find it there.
You got it. And these dense, high probability regions, those are what we call orbitals.
Orbitals. Okay, I remember those shapes. Spheres, dumbbells, that sort of thing. Is that connected to the electron acting like a wave-particle duality?
It absolutely is. The shapes of the orbitals, and so the overall shape of the cloud, they come from the electron's wave function, how it behaves like a wave, mathematically, around the nucleus.
So the cloud isn't just a uniform fuzzball. It has definite structure.
Based on wave mechanics, yes. So to sum up, the cloud is this picture of electron probability distribution shaped into orbitals.
Okay, cloud equals probability space. Got it.
Yeah.
Now, atomic shells, are they just like layers within that cloud or something different?
Think of them less as physical layers and more as allowed energy levels. That's the key.
Energy levels, like steps on a staircase.
Perfect analogy. Electrons can only exist at specific discrete energy states. They can't be in between. That's quantization.
Quantization, right.
And these levels are the shells, the principal energy levels. We label them N1, 1, 2, 3, and so on. Lower N means lower energy.
And closer to the nucleus on average.
On average, yes. Within that probabilistic cloud.
And inside those main shells are the subshells, the SPDF things.
Correct. And those subshells contain the actual orbitals we just mentioned. The structure gets more complex as it gets bigger, more subshells, more orbitals.
And how electrons fill these up. That's the electron configuration, following rules like Pauli exclusion.
Exactly. Pauli exclusion principle, Hund's rule, they dictate the specific arrangement. So crucially, shells aren't physical boundaries. They're the energy organization system for the electrons within the probability cloud.
Okay, that makes sense. The cloud is the space. The shells are the energy rules for that space.
You've got it.
All right. Cloud, shells. Now, the third piece, the atom's electromagnetic field. How does that work? Especially if an atom is neutral overall.
Good question. Every single atom is surrounded by an electromagnetic field. It just is.
Why, though?
It comes from the charged stuff inside it, the positive nucleus, the negative electrons, and really importantly, their motion.
So there's an electric part and a magnetic part.
That's right. The electric field is there because of the charges themselves. Even in a neutral atom, the positive charge is packed in the tiny nucleus, while the negative electron cloud is spread out.
Ah, so the charges aren't in the same place, effectively.
Exactly. That separation creates an electric field around the atom, especially nearby. It's like a tiny fluctuating dipole moment.
Okay. And the magnetic part.
That comes from electron movement. Two ways, mainly. First, an electron moving in its orbital is like a tiny electric current loop.
And currents make magnetic fields.
Yeah, that gives it an orbital magnetic moment. Second, electrons have this built-in property called spin.
Intrinsic spin, right, like a tiny bar magnet.
Just like that. It has a magnetic moment completely separate from its movement around the nucleus. So the atom's total field is the combination, the sum, of all these electric effects and all these tiny magnetic fields from orbital motion and spin. It's the atom's energetic reach into the space around it.
Okay. This is where it really comes together for me. How does knowing about the shells, the energy levels, connect to this external field and, what the atom actually does chemically?
This is the core connection, yeah. The specific way electrons are arranged in those shells and subshells, the electron configuration we talked about that directly shapes the atom's overall electromagnetic field.
So the internal energy rules sculpt the external field.
Precisely. And you can think of that field as the atom's interface with the world.
It's faced to other atoms.
Sort of, yeah. Everything an atom does when it meets another atom or interacts with light or a magnet, it happens through this field.
Okay, so the electrons way out on the edge, the valence electrons, they must be the crucial ones for the field.
Absolutely. They're at the edge of the cloud, generally highest in energy, and they define the characteristics of that external field that other things see.
Which means chemical bonding. That's
Yeah.
basically an interaction between these fields, driven by the valence electrons.
Fundamentally, yes. When atoms get close, their fields interact. Bonding, sharing electrons in covalent bonds or transferring them in ionic bonds, it's all about rearranging those valence electrons to reach a lower energy state.
And that happens via their electromagnetic fields. The forces are electromagnetic.
Correct. And this explains reactivity patterns, too. Think about noble gases.
Filled outer shells. Very stable.
Right. Stable, low-energy configuration. That leads to a relatively weak, very symmetric external field. There's no strong pull or imbalance in the field, so they don't really interact. They're inert.
But if that outer shell isn't full,
Then the configuration is less stable, higher energy, and that often results in a stronger, maybe more lopsided or asymmetric field. The field is kind of reaching out, making it energetically favorable to interact, to bond, to react.
and magnetism falls out of this electron arrangement too.
Directly. It all depends on whether the electron spins are paired up in the orbitals. Remember spin?
The tiny built-in magnet, yeah.
So if all the electrons in an atom are paired up, their spins point in opposite directions and cancel out. No net magnetic moment.
That's diamagnetism.
That's diamagnetism, weakly repelled by magnets. But if you have one or more unpaired electrons,
Their spins don't cancel.
right, the atom has a net magnetic moment like a tiny compass needle. That's paramagnetism. Those atoms are attracted to external magnetic fields.
Wow. Okay. So let me see if I've got this straight. The electron cloud is where the electrons probably are, like a probability map. The shells are the specific energy levels allowed within that cloud,
Yeah.
structuring it.
The energy rules, yeah.
And how the electrons fill those shells dictates the shape and strength of the atom's electromagnetic field extending outwards.
Exactly.
And that field is what governs how the atom interacts with everything else, bonding, magnetism, reactivity.
That's the unified picture. Cloud is our probability, shells are energy structure, field is the resulting interaction interface.
It really all comes down to electron configuration, doesn't it? How those electrons settle into their allowed energy states.
It does. Understanding the shell structure, the configuration, is the key because it dictates the field, and the field dictates the properties and behavior.
Amazing. So here's something to think about as you go about your day. Every single thing happening around you.
Chemical reactions, physical interactions.
Yeah, even light being absorbed or emitted, or why your fridge magnet sticks.
Yeah.
It's all being governed fundamentally by these invisible electromagnetic fields around atoms.
Fields that are meticulously shaped by nothing more than the weird probabilistic locations and the specific quantized energy levels of incredibly tiny things called electrons. It's kind of mind-blowing when you really think about it.